Hello, I'm Frank Sanders, Senior Technical Fellow at the Institute for Telecommunication Sciences, ITS, the Boulder, Colorado Laboratory of the National Telecommunications and Information Administration. I'm here to tell you in this talk about how the radio spectrum is managed at U.S. National Science Foundation, US Antarctic Program stations at McMurdo, Pole, and Palmer. This includes how to obtain and maintain radio assignments at these stations, and how to handle radio interference problems, including avoiding interference in the first place. The US NSF utilizes an enormous number and variety of radio systems to sustain USAP's activities. These systems support safety of life, navigation for air and maritime operations, station logistics and maintenance, and scientific data collection. Without radio systems, the USAP would probably not be sustainable. Good radio spectrum use, including avoiding interference problems, includes strong spectrum management practices. Starting by noting some terminology. Radio bands have allocations for the types of systems that can operate in them. The NTIA spectrum chart shows band allocations. Allocations are analogous to zoning regulations for real estate. They define what can allowably be placed in a spectrum band, but they are not licenses to operate individual radio systems. Permission to radiate actual individual transmitters, equivalent to an FCC radio license, is called an assignment. McMurdo has about 700 assignments. South Pole has about 70 assignments, and Palmer has about a dozen assignments. These assignments are managed and maintained in a database by a spectrum manager in the Naval Information Warfare Center Atlantic, NIWC. NIWC Atlantic has been supporting NSF and the USAP for aviation operations such as air traffic management, navigation aids, and air-ground communications since the 1980s, when the U.S. Navy was responsible for USAP operations. NIWC's support depends heavily upon the use of spectrum and was a natural home for USAP spectrum management support. Suppose you are planning to deploy a radio system to a USAP station. How do you obtain an assignment from NIWC's spectrum manager? You begin by obtaining access to the Participant Online Antarctic Resource Information Coordination Environment, Polar Ice. This is the web-based software application used to assist in deployment preparation and to coordinate and facilitate support for Antarctic research missions. Available at https://www.usap.gov/science-support/polar ice. When or if you are awarded NSF funding for USAP work, you will complete a Support Information Package, SIP, in Polar Ice for each deployment year. It will detail your logistical and support needs. Part of your SIP is a description of any radio systems that will need to be deployed as part of your work. In your SIP's radio description, you will include such critically important information as frequencies, transmitter power, and antenna characteristics. Remember, even if your radio system is receive-only, without any transmitter, you still need to enter its information into your SIP. The spectrum manager who is trying to keep your project interference-free cannot protect your system without knowing about your receiver's location, frequency, and antenna characteristics. In Polar Ice, you download an Excel spreadsheet form for your radio system or systems, populate it, and upload it to Polar Ice. Report updates as needed. Remember to include an expiration date for your radio system's operation. It helps spectrum managers make room for new radio systems to know when your system will likely no longer be operated. The NIWC Spectrum Manager will check your radio system against other systems already in the database to help ensure that interference between your system and other systems will not occur. This is why it's important to maintain accurate and complete radio system information in your Polar Ice SIP. Next, we examine how to approach suspected radio interference cases when or if they occur at USAP stations. The first step you should take is to ascertain whether your system's problem is in fact at the radio level. Some suspected radio interference problems turn out to be internal failures in data processing or handling. Depending on your system's characteristics, use logical troubleshooting approaches to try to isolate the radio level from the rest of the system and determine if the problem is in the radio level. If the problem appears to have been isolated in the radio part of your system, contact the local USAP prime contractor IT and Communications Department. They are the first point of contact for a harmful interference issue and can determine if it needs to be escalated to off-station experts, which can include the USAP Spectrum Manager service provided by NIWC. They also have spectrum measurement devices that can be used to identify other radio signals that are on or near the frequencies your system is using. Troubleshooting interference from other radio systems involves carefully characterizing the features of the interfering waveform. USAP has subject matter experts in the US, such as this speaker, that they can draw on for advice on specific isolation and resolution of interference sources. To avoid radio interference, good radio system design can help enormously in the first place. Although interference can, and does, occur when unwanted emissions from transmitters occur on receiver frequencies, interference can also occur when receivers are poorly designed. So, it is important to not only carefully filter transmitters to not emit power in adjacent frequencies and radio bands, but also to carefully design and build receiver inputs to reject power from adjacent frequency and adjacent band transmitters, which those transmitters are radiating on their assigned frequencies. And always remember to design, use, and maintain the best possible grounding in all of your radio systems. This includes your data transmission cabling that is not in the radio system per se. All data handling cables need to be coaxial with solid grounding to your system's power supplies and equipment racks. Maintain a common ground across all of the data system's equipment racks. We hope this description of radio spectrum management and interference troubleshooting will prove useful as you pursue your research projects at the USAP stations. For NSF's USAP, I'm Frank Sanders in Boulder, Colorado. Thank you.